Okay, so Bobby wants to know if housing prices have gone up this year. So that's the alternative hypothesis. The hypothesis you're trying to test, the thing you're trying to find out about is your alternative hypothesis. So that's why they said HA is mu is greater than 150,000. So what is the p-value of a right-tailed one mean hypothesis test? They've done all the work. They calculated the z statistic. They got the data. They got you the z. So to calculate the right-tailed the right-tailed p-value, you just need to find the area under the normal curve that's to the right of z equals 2.05. Okay, z equals 0 is the center. Z equals 2.05 has to be to the right of the center. So this is a sketch of the area. And when you use the z-score table, remember it always tells you the area to the left. So if I look up 2.05, that row and column lines up right here at 0.98. That's telling you this area to the left is 0.98. So the area to the right is 0.02. So that's our p-value. Okay. P-value is the area in the rejection region that's given by your test statistic. So in Newton, you got to move those dots. You want to move this down to the option that makes it a right-tailed test. Look, it's not two-tailed, it's right-tailed because we're only looking for one direction, greater than. If it said the mean is different than 150,000, then you'd be choosing this option. And then you want to move it until you get to, I think this is a z-score, 2.05 is where you'd want to put it. And it should have that p-value that we got from the table when you move it. Okay, and so correct interpretation, this student chose this option, but let's go through the probability of observing a value of z equals 0 equals 2.05 or more under the null hypothesis is true is 2%. That is the correct answer. The probability of observing a value of z equals 2.05 or more if the null hypothesis is true. So when you conduct a hypothesis test, you assume that the null hypothesis is true. And then you calculate the probability that you got this z-score under that assumption. And that's what the p-value is. There's a 2% chance that we got this z-score assuming that the null hypothesis is true. That's pretty unlikely. So that's why we say we reject the null hypothesis in favor of the alternative, because it's really, really unlikely that the null hypothesis is true. Let's see why the other ones are wrong. The probability of observing a value of the z-score or less, that would be a left-tailed test. That's why we ruled that one out. Same thing here, or less, it's a left-tailed test. So that's let's see, probability of observing a value of z equals 2.05 or less and the null hypothesis is true is 98. So if it said 98%, that's right, but that's not testing the null hypothesis. That's not testing to check to see if the alternative hypothesis is true. So that would be a true statement if this said 98%, but that doesn't help us because we're not doing a left-tailed test. We shouldn't be doing anything to the left. So when you make a statement, if you have a greater than symbol, you should be only talking about right than, something greater than. If it said mu was less than 150,000, then that would be the right answer. Okay. If it said mu was not equal to, then you'd want to look for the answer that says that it's different. The probability that it's greater than or less than. So the probability of observing values, no, so this isn't right because that is the area to the left. 98% is the area to the left. Being greater than 2.05 is 2%, not 98%, so that's why that one's wrong.